Hello, good evening. Welcome to this session. And in this session, I'm going to discuss the three methods to evaluate this integral e to the power x into sine x dx. This question must have appeared in your standard class textbooks. Let us see. So the first one is simply to integrate this by parts. So of course, so if I do by parts, that is my method one. So method one is to do by parts. That's the standard method. So here I'll be considering integral e to the power x, and then here I have this is sine x into e to the power x dx. Now in this case, if I apply by parts, then this is u, and here this turns out to be v. So that is sine x, and then integral e to the power x dx minus the derivative of sine x, and then the integral of e to the power x dx and the whole dx. Now later this turns out to be sine x, and this guy is e to the power x minus the derivative of sine x is cos x, and integration is e power x dx. So again, this term to be again by parts. So let's consider this will be cos x, and then integral e to the power x dx minus the derivative of cos x, and then integral e to the power x dx, and then the whole dx. So if I consider this part, so e power x into sine x minus, this is going to be cos x into e power x, then minus of minus will be plus, but then derivative of cos x will be again sine x. So this will be minus of sine x into e to the power x dx. And I see that my I has reappeared. So I'll just consider this part to be I. And this would give me simply 2i is equal to e to the power x into sine x minus cos x plus c. We can divide by 2 to get I value. This turns out to be e power x over 2 into sine x minus cos x plus c. Of course, you could write c dash, that's by 2. So that's my method one. Now let's go for method two, which I did in my class. Method two. Method two, it simply uses a rule, which you might be knowing, and this is integral e to the power x into f of x plus f dash of x dx. So this turns out to be e power x into f of x plus c. And it simply works on the principle, since we know that the derivative of e power x into f of x is simply what? So e power x into f of x as it is plus f dash into derivative of e power x is this thing only. So simply I just use the integration. So to use this part, what I'll do, I'll consider e power x into this is my sine x. So now the goal is to find a function and its derivative here. So I'll accordingly choose a function. So the derivative of sine x is actually cos x. But then if I adjust plus cos x, I have to do minus cos x also. So for that, I need to have here 2 sine x. So in that case, what can be done is integral e power x, and this sine x, I would be writing sine x and then plus sine x. And if I do here minus cos x and then plus cos x. So if I look at this, then this is my function f, and here is the derivative f dash. The sine derivative is cos, and minus cos is plus sine. Sine derivative is cos, minus cos is plus sine. So this turns out to be derivative. So you directly get this e power half into e power x, and then sine x minus cos x plus c. So that's method 2. And now let's see one more method, 3. So we have another method, 3, that turns out to be, say I want e power x into sine x dx. Then I'll be using the Euler's identity. So that is e power ix is equal to cos x plus I times sine x. So I'll be using this thing. So since e power ix turns out to be cos x plus I sine x. Now I want to integrate e power x. So what I'll do, I'll multiply this equation by e power x throughout. And now I'm going to integrate this entire equation. So I get integral e to the power 1 plus I times x dx is equal to, the real part will be e power x into cos x dx plus I will turn out to be a constant outside, so e power x into sin x dx. I'll call this equation some star. And now if I integrate this guy, so integral e to the power 1 plus I times x dx will be simply e to the power 1 plus I x over 1 plus I. The constant should be divided here. And this would give me e power x outside. And 1 plus I, 1 minus I, I'll write down here 2. And this gives me e power ix into 1 minus I. Here I have taken the conjugate and then multiplied. So now this could be written as e power x over 2 into e power ix is cos x plus I times sin x into 1 minus I. So this would be e power x over 2, and then now here I'll multiply this thing. So this gives me cos x, and then minus I cos x, and then plus I sin x, and then plus sin x. So now in the next step, we're going to write down the real part and imaginary part separately. So this gives me e power x into cos x plus sin x. That's my real part. Plus I times imaginary part would be e power x into, and then sin x minus cos x again. Sin x minus cos x. So that means I know that this integration turns out to be that integral e to the power x into cos x dx plus I times integral e power x into sin x dx would be e power x by 2 into cos x plus sin x, and then plus I times e power x by 2 into sin x minus cos x. So just equate the real and imaginary part. So this actually leads to one more integration like this, and you get there e power x into sin by 2 into sin x plus cos x. And then if I compare the imaginary part, then I get my required integral, that is e power x sin x dx is equal to e power x by 2 into sin x minus cos x. Plus you will add with love. Okay, that's all. Thank you so much for watching. Bye.